Today we're going to work on 12.6, which is to add and subtract rational expressions. That little paragraph up there is to remind you that adding and subtracting rational expressions with the same denominator is similar to adding and subtracting numerical fractions with the same denominator. If you have two fractions with the same denominator, like from your homework, what did you do in order to add those two fractions together? You had two fractions that had a common denominator. What did you do to them when you added them? Alex? You add their numerators, and that's what we're going to be working with today too in our rational expressions. We're going to be adding numerators, but we're going to have to make sure that we have common denominators, and rational expressions have polynomials in them. So we're going to be working with common factors that look like monomials and binomials. Sometimes they'll start out looking like trinomials. We are on the second of two last sections. We have 12.7 yet. I believe you have a quiz next Friday, so keep that in mind, a quiz next Friday. We're going to add and subtract with the same denominator to start out with here. I have 2x over x plus 2 plus, hold it just one moment. I think I'm out of order. I am very much out of order. I want this least common denominator. No. I'm in order. Excuse me. It's Friday. Believe me. Yes. Let's add these together. We're going to talk about common denominators first. We're going to add together what is there. So Alex commented, add the numerators together. And so write this with the same denominator, x plus 2. And on the top, we're looking at 2x plus x plus 1. Most of you probably would add those in your head. What's going to be my numerator? What's it going to look like, Brandon?
3x plus 1.
We're going to have 3x plus 1 all over the x plus 2. Can you factor the numerator at all? No? Then we have nothing that we can cancel between numerator and denominator. We're done with that one. Okay. When you add them together, usually you'll be pretty much done in the numerator there. Maddie?
Do you have to add in the x can't or -2 or no?
We will not need to do that in this section. Okay. We will not need to do that. What x, the excluded value. Let's look at this next one. It's a subtraction problem. Why don't you take a look at putting this one together? Go ahead and talk to your partner if you want to, and we'll see what we come up with. We have our 4x plus 1 minus. I want to caution you when you're writing this, this is minus the entire x plus 3 that follows it. It does not get put in the denominator. It's only in the numerator. Do you remember to put down that negative? And then that gets distributed to everything inside there. So what are we going to end up with simplified in the numerator, please? Eddie?
3x minus 2.
3x minus 2 all over the 5x. Any factoring that can happen yet? No? Then we're done with that one. When you have common denominators, life goes pretty easily, it looks like. Any questions so far? Why don't you do these couple? We'll get some people up to the board to put these answers up here in just a moment. First one was pretty easy, just adding your numbers together and your variables together on the top, y plus 3 all over y. Nothing else to do with that one. The second one, you had to distribute that negative inside the parentheses, 2x minus 3, so that we ended up with 2x plus 4 in the end, all over 2x minus 1. What we're going to find along the way here is that our numerator is going to end up probably as a polynomial that we cannot factor. And so we'll be leaving it as it is. I know you can factor this one, but it doesn't allow you to cancel it all at the end. And so I got a feeling the author would probably leave this one as 2x plus 4 as an answer. Okay. I will try to put in my directions whether I want it to be all factors or whether you can leave the numerator multiplied together. I think with this section, they're leaving all of the things added together in the end. On the top, the denominator, they are leaving in factored form. Do not multiply your denominator factors back together. Do not multiply your denominator factors back together. Anyone not understand that? Abby?
Okay, so like on like our quiz and stuff, do you want us to show in our work that we're distributing the negative?
Kind of depends on how tough it is, whether you need to or not. Okay? On something like this, you could probably do it in your head. Okay, now we're going to start talking about least common denominator. When you think about least common denominator, think about the factors that one denominator has that the other one doesn't have. And may I say, the denominators are greedy. If one has it, the other one wants it. So you have to give it to them. Okay? So if you look at 12 and 4, what factor is one of the denominators missing just between 12 and 4? Eddie? Between the numbers 12 and 4, what is one factor that the two denominators both want to have? Nick?
With it, both one.
What is missing in one of them? Between the numbers 12 and 4, what factor is missing, Dan?
6.
Brandon?
4.
Bill?
3.
3. This one is 3 times 4. Okay, so I need to multiply both of these by 3 in order for them both to have a 12 in the denominator. They're missing a 3 in that one. Now, one of them has an x squared, the other has an x. The first one is missing. What's the first one missing? Elise? An x, so we're going to have to multiply by an x on both top and bottom. If you look at the denominators now, we have 12x squared here and 12x squared on this one. They both have to have all factors that are in common. Okay, in the end, they both have to have all the factors. If they don't have one of the factors that the other denominator has, you must multiply by it on both top and bottom. So in this case, we're going to end up with x over 12x squared. And on the other one, we're going to end up with 3 times x plus 7 over 12x squared. So far, I'm not adding or subtracting them together. I'm just getting common denominators and equivalent fractions. That's all I've done so far. Eddie?
So you want us to leave it like 3 times quantity x plus 7 and not?
You'll need to multiply that in when we start adding and subtracting to be able to add like terms, Eddie. But for right now, we don't have to. Okay? Anybody else? I will make you do more work than you need to right now. Here are 2 expressions. Talk to your partner and decide what does one have that the other one doesn't. What do we need to multiply our fractions by? Talk to your partner about that. Okay, so Maddie, what are we going to multiply by?
X plus 1 on the left and x minus 8 on the right.
Okay, the entire binomial is a factor. And so here I need x minus 8 and x minus 8. Please notice all my parentheses. X minus 8, x plus 1 are binomial factors. Since the first fraction didn't have x plus 1, we had to multiply by both top and bottom. The second fraction didn't have x minus 8. We had to multiply both top and bottom. I think you can probably see into your future a little bit here. When we start adding and subtracting these, you're going to have to be able to add like terms in the top. So you're going to have to do some multiplying and then add like terms. Yeah, I think that was Eddie's question from a little bit earlier, where we're going to have to multiply. Okay, the future looks so bright, doesn't it? You just might need shades, right? Eddie?
Well, why can't we just multiply by a -8?
Because a -8 is not a factor. A -8 is an add-in to the x. It's x minus 8. It's a binomial factor. Okay, it's a binomial factor. Mackenzie, do you have a question? No, Nick? Okay. So we're okay? Let's go a little bit harder then. Take a look at these and check out what the factors are and see what you have to multiply by to have common denominators. Feel free to talk to your partner. Some of you are stuck on that bottom, trying to come up with what the common factors are. First thing we have to do is factor the denominator of that first fraction. So x squared minus x minus 6. What is that factored into for two binomials? Okay, that's our 9.5 factoring. Elise?
X plus 2 times x minus 3.
X plus 2 times x minus 3. Okay, and in our numerator is 4 still. The other one has x plus 2 times x plus 2. It's written twice. Okay, squared. This one over here, the first fraction, is greedy. It wants what it doesn't have in this denominator. So what are we going to multiply this first fraction by? Okay, Madeline?
X plus 2.
X plus 2. So I got to go up on top here, x plus 2. Now it has 2x plus 2's, just like this one does. The second fraction is greedy and wants what the first fraction has in the denominator. What are we going to have to give it? Bill?
An x minus 3.
An x minus 3. Okay, and that has to be multiplied by on the top as well, because that makes us multiplying by 1. Now notice, an x plus 3 on the bottom here, and an x plus 3 on the bottom on the other one. Now, both fractions have all of the factors the same. And now the numerators, when we start adding and subtracting in just a little bit, will have to be multiplied together, and then common terms added together. Okay, we'll be multiplying these two together, we'll be multiplying these two together, and then we'll be either adding or subtracting possibly here. You with me on the common denominator so far? Coming up with them? Light bulb starting to go on with that? Now don't write this down. To add or subtract rational expressions, you need common denominators, just like you do with fractions. You guys were working on that. So here we'll start out fairly simple. 6 over 18x plus 4 over 6x squared. Get common denominators, get equivalent fractions. Once you do, go ahead and add the numerators together. Feel free to work with your partner on this.
Okay, sorry.
In looking at this, I like that Maddie and Alex over here showed me what they're multiplying by, both in the numerator and the denominator on both fractions. They showed me that they're multiplying by x over x and 3 over 3. That would be a really, 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 really good idea, hint, hint, wink, wink. So that in the end, you're multiplying, you're getting things correct, so that you can see what you're doing. I can see what you're doing. Maybe there's partial credit along the way if I can see what you're doing. In the end, Maddie did simplify. She factored out that 6, which canceled with the 18. I do expect your answers in lowest terms, the simplest form. So if you can cancel, you should. So look for that. Perhaps we could have started looking right here and said, I can simplify this. I can simplify here, and then you would not need to simplify at the very end. It's an idea for you, but you still need to simplify when you're finished if it's not. Okay, questions there? Okay, let's make things a little bit harder. Okay, please work with your partner on this one. On the first fraction, what are you going to be multiplying the first fraction by so that it has denominator that it wants? Nick?
X minus 1.
X minus 1, so we're going to multiply by x minus 1 over x minus 1, not just a negative 1. That's a binomial factor over here, so x minus 1 goes together as a group. What are we going to be multiplying the second fraction by, please? Brandon?
2x.
2x. So we're going to multiply this by 2x and this by 2x. So that in your denominator now, you have 2x times x minus 1. In the numerator, multiply these two together, 5 times x minus 1. What does 5 times x minus 1 give you, please? 5 times x minus 1, Madeline?
5x minus 5.
5x minus 5. Then minus the 2x times the 3x. Well, what's 2x times 3x, please? 2x times 3x. Brandon?
6x squared.
6x squared, so I'm going to go minus 6x squared. I could rewrite that so that I have from highest degree down to lowest degree here. In my denominator, I've got 2x times x minus 1. Okay, take a look at that. Even if you factor out a negative in the numerator so that you have 6x squared minus 5x plus 5, can you factor that trinomial? Nick?
Well, I don't know, but I did something else different.
Well, this is correct so far.
I know it's correct, but I did something else after that.
What did you do?
I factored out an x between the negative 6x squared.
No, you can't do that.
Oh.
Okay, if I take an x out between the two, just for the sake of argument, Nick, then what were you going to do with it?
Cancel.
With the x down below?
Yeah.
You can't because you have a negative minus 5 still connected to all this.
Right.
No, I can't cancel that because, yes, this is multiplied by this minus 5. The minus 5 is still connected here. I cannot cancel this x with the 2x down, or with the x down the denominator, because these are just being multiplied together. This is multiplied with subtraction. This is an expression up here you can't break up. If I take an x out of here, I have to be able to take an x out of that negative 5 as well.
Oh,
And I can't, yes. Okay. So, you could try as you might to factor using guess and check, British method, but that's where we'll stop on that one because it can't be factored in the numerator. You like that one, didn't you? You may see several of those kinds. Remember when I commented earlier about could we have simplified the fractions at all? Take a look up here. Could you have simplified those original fractions? No, then probably what you're pulling together will not be able to be simplified either. Okay, Alex?
I didn't get anything like close to what you got. Like, could you still do like the British method on the top?
In terms of factoring it?
Yeah.
Yeah, you can factor, you can try to factor it, but it's not factorable.
Gotcha.
Because if I take, let's say I take the negative out and I have 6x squared minus 5x plus 5, which makes the British method much easier for me.
Okay.
Okay? 6 times 5 gives me 30, agreed?
Yep.
And I want the factors of 30 that add up to be a negative 5. Can you come up with any?
I didn't believe I could.
Then I'm done. I can't factor it. Okay? Anybody else? Tina?
So you don't multiply the denominator.
No, remember I said that twice very distinctly earlier? Do not multiply the factors in the denominator back together. Period. Exclamation point. Alex. Go ahead and take care of this one, please. Up on the board here, we have shown that we are multiplying by 5x to the third, because this one already has an x, but it needs 3 more to be x to the fourth. So whatever it doesn't have to be equal, it must multiply, and it needs that 5 as well. Over here, we're just multiplying by 2, because, yeah, there was an x over there, but I've got 4 of them over here, so all it needs is just a 2 yet to be multiplied by, because there was a 2 over here. Eddie?
Could you use that 15x to the fourth and 15x to the third?
Yes, I will. So you want,
I was thinking of the fourth.
so you want x to the third here, and you want x to the third here? All right. So now when we multiply these together, we will have the 15x to the third plus 14 all over 10x to the fourth. If you multiplied by 2x on both of these, then you're going to have an extra x sitting out there that you're going to have to get rid of. And that's where you have to be careful. Do I really need to factor at the end or not? We don't want that extra x out there. We don't want to have to get rid of that. So don't have those extra factors. Okay. Questions, Dino?
We're supposed to multiply the denominator.
Well, this one is, I mean, constants, multiply them together. Don't leave it out there. It's 2 times 5. 2 times 5 is 10. I don't want you multiplying monomials and binomials back together in the denominator, okay? Anybody else? You might need to do a little factoring first, huh? Okay. On the top, or excuse me, on the first fraction, we've got x plus 3 on the top. What are our denominators for the bottom, please? What are our denominators? Cole?
X minus 3 and x minus 5.
X minus 3 and x minus 5. All right. Then, what are our denominators for the bottom of the second fraction? Alex?
X minus 6 and x plus 5.
6 and 5 give you 20 here?
6 and 5.
X minus 4.
X minus 4. Well, let's think a little more. Brandon?
X plus 4, x minus 5.
Okay. Now, we have to determine what our common factor is. So what are we going to be multiplying the first fraction by? What are we going to multiply, AJ?
X plus 4.
By x plus 4. Okay, x plus 4 here and on top of here. And yes, you will have to multiply those two binomials together. What are we going to multiply the second fraction by? Dan?
X minus 3.
X minus 3, both top and bottom?
Yeah.
All right, and we'll put parentheses here, and yes, you're going to multiply those two polynomials together. So I need you to FOIL x plus 4 and x plus 3 for me. If I could have that FOILed, Elise.
X squared plus 7x plus 12.
All over, we're going to start writing down x plus 4 times x minus 3 times x minus 5. How about the second two binomials, Madeline?
X squared plus 3x minus 18.
Minus 18. And what I'm going to do up here is I'm going to put in minus everything that Madeline just told me. Remember, you have to distribute that negative. So now add your numerators together, please. Add your numerator together, and let's see what we have when we combine like terms in our numerator. Nick?
I got 4x plus 30
4x plus 30 over.
over x plus 4 x minus 3 on the x plus 5.
There you go. Now, if you were to factor 4x plus 30, it'd factor into what, please? If you were to factor that, AJ?
2 times the quantity, 2x plus 15.
2 times the quantity, 2x plus 15. Does that help you in canceling at all? No, then don't worry about factoring it. Done. Okay. Can you see where you're going to need to write down what you're doing on both of the fractions? You're going to need to do some FOILing. You're going to need to add some terms together. You're going to have to do some factoring. Everything we've been doing for the last 9 weeks. And prior to spring break, so about the last 12 weeks, all put together in one.